Welcome to FlowStars, candid conversations between Dr. Peter O'Toole and the big hitters of flow cytometry. Brought to you by Beckman Coulter at Bitesize Bio.
Hello and welcome to this packed episode of FlowStars with the one and only, one of the biggest names in flow cytometry, Mario Roederer. And he talks us through the highs and lows of his long career, including how poorly he was thought of in grad school, demonstrating cytometry to past presidents Bush and Obama, and the importance of developing pipelines to prevent copy-paste errors. All this and more coming up in this episode. Hi, I'm Peter O'Toole and welcome to this episode of FlowStars. Today, I'm joined by Mario Roederer from NIH still? Mario?
Yes. Yep.
Do you know what? It's a real honour to meet with you. I reflected back to when I started my flow cytometry career, and there were, for me personally, there were three big names in flow cytometry. There was Howard Shapiro, Paul Robinson, and yourself. And I've been so fortunate to meet all of you, and to actually get you to record today is a real honour. So thank you for agreeing to today, Mario.
That's my pleasure.
So just to give you an idea of how important Mario is, if you haven't met Mario, I've been looking. You've actually met Barack Obama, haven't you?
Yes, and George Bush.
And George Bush.
Yeah.
This is huge.
I got to show them how flow cytometer works. In fact, with Barack, we had the LSR2 open up so he could look in and see the lasers and the paths. And I had this nice display where we had 6 different tubes of quantum dots lined up. So if you hold it to the laser, it looks like the laser changes color as it goes through because they emit different wavelengths.
Oh, that's super smart. Because, to keep them engaged, and even if it's not true science per se, it shows and gets them excited, I guess.
Yes. And actually, Obama asked some very pertinent questions. It was pretty impressive. I was impressed by him quite a bit.
How long did you get with him?
About 5 minutes.
Still, I'll take my 5 minutes of fame at that point.
And then I got to ride in the motorcade over to a different part of NIH where he made a major speech. So that was kind of fun too.
Ah, that's got to be one of your highlights in your career, hasn't it?
Yeah.
That's pretty special. And it also shows not just your importance, but the importance of flow cytometry, which is obviously what you're famous for worldwide, is the flow cytometry side of things. What got you into flow cytometry to start with?
Well, that I have to blame on Bob Murphy, my PhD advisor at Carnegie Mellon. I went to Carnegie Mellon for my PhD, and I joined his lab. And he used flow cytometry to look at endocytosis. And so I started working with him on that aspect. And I remember for my PhD thesis, that proposal defense, which you give after 1 year, I actually proposed to do a 7-color experiment, which was absolutely unheard of. And by the end of my PhD career, I was doing 2 or 3 colors. So I was a little bit ambitious, but it set me on the path.
So just for ease, this has got to be the late 80s?
No, 1984.
1984, and wanted to do 7-color flow cytometry.
Yeah.
And I think we had to wait to the start of the noughties.
No, we were doing 9-color in Lens Lab in 1998 or so.
I wasn't far off.
No.
I wasn't far off. And I guess that's how I know your reputation is color, the number of colors that you can actually apply and do it sensibly.
Yeah.
How many world records for the number of colors on a flow cytometer? How many times have you broken that personally in your lab?
Oh, probably about 18 or so. But the one I'm most proud of is we had a student in the lab who was 22 years old who planned and implemented a 23-color experiment. And it's the first time anyone had ever done more colors than their age.
That's super cool, isn't it? And I guess that's going to be more and more common now as the number of colors you can do by flow cytometry has increased. We will come back to multicolors in a bit. But you got into flow cytometry through your PhD and what you wanted to do. But if I take you back to when you were 10, 11, 12 years of age, can you remember what the first job was that you ever wanted to do?
Well, I always knew I'd be a scientist. My
Really?
my father is a physicist. He's now 95 and still writing physics articles. My brother, who is 10 years older, went into neurobiology initially, and so I suspected I would always be a scientist at one level or another.
Oh, wow. Yeah, I've got to ask, what line of physics was your dad, or is your dad still in?
Space physics
Space physics.
and yeah, near Earth physics.
So you never wanted to be an astronaut?
Of course. In fact, there's a group down in where are they? NASA Goddard that does flow cytometry for space physics for the astronauts. And I always offered that I would go and work their I'd be their flow jockey if they needed someone in space.
Oh, come on, with the way things get going in space travel, it's not beyond it yet, is it?
Not yet, no.
Can always hope. So, okay, so your dad was a physicist. Your brother, who's 8 years older, went into neurobiology. But what was your first degree
Chemistry. My father convinced me that I should get a degree in a hard science, not in a soft science. And so I decided to go with chemistry because I was basically a pyromaniac. And I thought chemistry would be a good way to learn how to make explosives and things like that.
in? So,
But then I kind of lost interest in chemistry when I took my first genetics course as a freshman in college, and I fell in love with biology and genetics, and I always thought I'd be a gene jockey when I went to graduate school.
so what changed? Just through your PhD that changed.
Yeah, I think joining Bob's lab and seeing the being able to do technology development, I've always been somewhat good at technology. And the gene jockeys didn't need any technology development. They just needed creative people who could do biology, and that's not me. So working in Bob's lab, I got exposed to developing technologies, both the hardware and the software, because I also wrote acquisition packages back then in the early 80s that BD gave away with their instruments. And so that kind of got me hooked. And then from the biology side of it, flow cytometry was heavily used in immunology. So just through the technology, I got exposed to immunology, which I love. That's my love. And so I went to Len's lab as a postdoc to do immunology and flow cytometry, Len Herzenberg, and the rest is basically history.
Well, what was Len like to work for?
Len was fantastic. I admire him so much. He always had the philosophy that the science belonged to the people because the people paid for it. So he had the initial patent holders on the flow cytometer. He asked that they sign over their rights and money to the lab, and so he was able to fund the lab quite well, and always felt that the science was owned by the masses of people who paid for it.
And what was if I take you back to the start, what was the first flow cytometer you used?
In Bob's lab, it was a fax 440. That was the first sorter, and we had a three color analyzer. No, that was not. We didn't use that. But it was a 440 fax 440, which is a fax 4 based machine. And then when I went to Len's lab, we actually had a fax 2, which became our first 11 color machine as we slowly added on different detectors and electronics to it. But that was the fax 2 that's now in the Smithsonian.
Oh, wow. Have you actually seen it in the Smithsonian?
Nope.
No. Are you tempted to go and see it?
Yeah, I think it's not. You have to wait until it's on display. Every so often they'll bring it out on some sort of special display. So right now it's just in a warehouse. It's like
Oh,
Raiders of the Lost Ark, that last scene.
well, that would be cool, though, wouldn't it?
Yeah.
We should look at an anniversary date and try and persuade them to celebrate the anniversary and bring it out on display? And
I should have thought of that 4 or 5 years ago because I'm pretty sure those special displays are concocted 5 years in advance.
yeah.
But yeah, that would have been fun.
And so that was your first cytometer. Do you have a favorite cytometer that you've ever used?
I think the LSR2 was my favorite just because it was so easy to use and it was the first cytometer we had where we had really good resolution of different colors and so on. And it was also digital. So I think the different aspects of it made it my favorite. Plus, I'm basically responsible for the LSR2 in BD because I went to them and told them they had to build this for me. And they did a market analysis and said they would do it if they could, because thought they would sell 50 of them in the next few years. And they ended up selling 2,000.
Yeah, the market exploded though, didn't it, for Flow? It has, and it's still
Absolutely.
growing, isn't
Yeah.
it? Just incredible. So I've got to ask, have you ever had a MoFlow?
Yeah. Well, we had our original cytometer in LensLab, which was a Fax2, had the multiple electronics. Because the electronics was the only we could do high-speed sorting and we could do digital acquisition and so on.
I've got to say that for me,
So it was the multiple electronics on top of a Fax2 bench.
just a different era. I miss the MoFlow.
Yeah.
I do miss it. So you mentioned earlier about the software side, and you were actually playing with the software for the analysis, because obviously the analysis, old school, was very literally analog, very analog.
Right. Yeah.
So it's not everyone who is into actually computer programming and helping with the analysis and the setting up the software side of it. Why get into that side of it? You could just be a user asking for more colors. Why did you feel compelled to help and address that side, the analysis
Well,
side?
I didn't feel compelled. For me, it's just easy. Writing software for me is easy, and I have to be very careful because it's distracting enough that if I have a hard problem in biology that I don't want to deal to, I'll start writing code. And coding is it's addictive for me because it's easy and you can see right away the benefit that you're having. But initially, I was doing it primarily because we needed to be able, as we moved on beyond 3 and 4 colors, we needed software that could do compensation, which did not really exist at that time. And we needed to do it in an automated and high-speed way. So that's why we initially started writing FlowJo in LensLab, was to have the ability to handle the data sets we were generating, which were beyond any software that existed at that point.
And so now you brought onto the FlowJo, because you are the founder of FlowJo. And for those,
Adam Treester, we hired Adam Treester into Stanford because he was a real coder, and he and I generated the first version that was commercialized.
And for those listening, if you don't know what FlowJo is one of the leading flow cytometry analytical software programs. You'll find this in hospitals, you'll find this in almost every university that's out there. It is absolutely fundamental and fundamentally important. And the software itself, I don't know if you've ever reflected on this, the amount of fundamental research that FlowJo has enabled, it is uncountable. It's huge.
Yeah.
And that's because of yourself.
Well, someone would have had to do it, but yeah, I happen to be fortunate enough to be in a position where I could do it and did do it. But I do remember going to talks in the mid 90s and later on in the 2000s and so on, where I'd see plots on people giving talks and they'd show a plot that I knew was FlowJo because it's like your child. If you have twins, as a parent, you can tell them apart, but other people may not be able to. So I can always tell a plot that comes from FlowJo versus a plot that comes from somewhere else. And I would see it more and more used and presented. And I thought, well, this is something that I think is going to be big. And it was.
And he's still huge.
It's still right.
Still the leading program, I believe, in the
Yeah.
market. I've got to be careful. As part of this series, I'm doing Dave Novo as well. Obviously, who does the leading rival software, arguably. but it's not about the software, is it? It's about the history of it and just the success. And what was it like? So you started a company for FlowJo. How big a step was that? Because that's, again, a very different step from just being in academia, doing research, now having a spin
Yeah,
out.
so that was primarily Adam, the co-founder of FlowJo. He had a company that he used to sell very niche software from, and so that was TreeStar Incorporated or TreeStar LLC. So we licensed the software technology from Stanford, who owned it at the time, and then developed it more and commercialized it and started selling it through that portal, basically. So Adam really took care of the business end of the software for 20 years.
Did it take a lot of your time though? Because there's one thing having software that works in your hands for your lab. There's another thing once it becomes a commercial product that the user interface has to be glossier, more user friendly. Were you involved in a lot of that, or was that part of Adam's side and his team?
I was involved somewhat. In general, I'm not a user interface kind of guy, as you correctly point out, because that requires a lot of patience and a lot of knowledge. So I did more of the algorithms and the basic. I needed something, so I would code it and implement it. Back at Stanford, I did a lot of that. So yeah, it consumed a lot of time, but it also saved a lot of time as a consequence. So while it would take me an hour or two to write a new algorithm or a new interface or so, it would save me that time in spades down the road as I used it over and over in the lab as well.
It's fascinating listening to you. Actually, I have a data science team at York, and they're always telling me that it's vital for them to develop the pipelines to do the analysis. 'Cause it's quicker to do that than to do grunt through the data analysis itself.
Yeah,
And what you're saying perfectly chimes with what they're telling me all the time. That no, better to do the pipeline, get the coding, and let it do it for you, because then it can just.
and I continued at NIH where I had my own lab. I would write pipelines in different softwares like the JMP based software JSL, which is Jump, a program that's put out by SAS. I would write pipelines in there to assist with people to do their analysis or to automate their analysis. I've always felt that you don't want to do, you need to have automated analysis so you can always start from the raw data at the beginning, no matter how, as you add more and more data to it. You always reanalyze use the pipeline from the beginning so that you don't make copy paste errors. One of the biggest problems in science right now is too much of it is done with copy paste. And so you get halfway down an analysis scheme and you realize you did something wrong and then you have to go back and do it again. So that's been my main effort not main, but that's been one of my big efforts in the lab I run, is to help them with the pipelines because I know how to write those.
So I've not thought about this until just. How do you, so the cytometers themselves are now so user friendly that you don't have to be very expert at all to be able to operate the analyzers or sort of. They are super use. They've made them super good for immunologists, other biologists, life scientists to use. The likes of FlowJo make it really easy to analyze the data. Do you think there's ever a concern that people are so disengaged with what they're doing and they're just putting tubes on the machine and spitting out data analysis at the end, that they may misinterpret or design their experiments badly? Do you think we're getting more of that because they're less techy and less thinking about what's really going on?
I think it's a real problem. I think it's always been a problem. And there's no easy solution. I mean, to me, the solution is not to make sure that the users know how to do all those things or how the instrument works. The solution is to embed the people who run the flow cytometers in the lab so that they can participate in the design and implementation of the experiments. But it means you always have to have people who sit on the fence of technology and biology. You need to have people who understand both sides and can translate. They don't necessarily have to be experts at either one, but they have to be able to translate. And that's something that I've always been proud to be able to do, is to sit on that fence and talk to the biologist and say, what do you need? And translate that to the technologist. Because a lot of the time people will say, oh, I need to be able to do this. A user will come up to me and say, I need to do this. And I'll go, well, no, that's not quite true. You don't need to do this, but you need to do that, which is very similar. And then if you implement that, that helps them do whatever they wanted to do. And the reason is because users don't necessarily know how to code or what the appropriate pipeline impact is. And then if you have people that'll happen the opposite side, where you have software engineers who'll say, oh, the users will want to do this. And I'll sit there and go, no, that's not really what they want to do. They want to do that, and you should code it this way. So
No,
it's you need to have people who are sitting on that fence who know both the technology and the biology, who get embedded in the biologists in terms of experiment setup and implementation and so on. And in
yeah,
a sense,
very lucky.
that's why Johnny Moore and I wrote our article about shared resource laboratories back in 2003 or four or so, where we put forward that whole concept that it's not just a core laboratory anymore; it's a shared resource laboratory. And the idea of calling it shared resource was to convey the fact that you want to share the design and share the knowledge of the technology with that of the biologist, so that you get the best of both worlds.
In shared resource, so I'm very lucky. We've got a shared resource facility, and I've got an excellent team that sit on that fence and interface between the two, and are very integrated. I would say the users are more dependent on the technical staff than they are on the instruments. You know,
Yes.
the way the system works now is they are almost dependent on them to help design their experiments. There's a lot of teaching, a lot of training. We have lots of external courses to help train, but when it comes to the complicated stuff, they still heavily lean on the team that we have, and that is the perfect shared
That's
resource.
great that it's great that you can provide that. But my fear is that the instruments become so simple and inexpensive that people can buy them for their own laboratory and never get the training or assistance that they really need.
Do you think this is an art? If you think about it, this is a blessing of financially challenging times, in that it makes it harder, even though the instruments are getting cheaper. So I'm sorry for all the manufacturers out there making cheaper ones. The running costs are not insignificant. The service contract costs of these instruments, it becomes a burden to individual labs, and that actually, so because of that burden, it's encouraging more and more not to put them in their own labs, but to put them in a shared resource. There are no other flow cytometers at York but in the facility, and there's 5 analyzers, I think, 3 sorters, all just in, and no one would want, I don't think any of the users would want their own, because they've got 5 at their disposal. So if one was to break, there's another 4. They can have multiple people on them at the same time. So it's very much a cultural persuasion to explain the benefits of those shared resources are more than just the cost.
I think too many people view flow cytometry, or used to view flow cytometry, as a centrifuge. You come with your samples, you put them in, you press a few buttons, and you come out with your cells at the bottom and the fluid at the top. And that's, for flow, it's a far more complex technology that requires a lot more thinking and processing and understanding the impact of every step on your experiment and so on, and optimizing the panels and using reagents. I mean, it's amazing how people still don't know what reagent titration is about, and what the antibody binding kinetics, what mechanism kinetics will tell us about binding and so on. Those are all important facets of a flow cytometer experiment, and yet they're still not widely understood. Or
I've always thought, remember the first, without naming any names or anything else, but the first user-friendly cell sorters, and they got quite a bad reputation early on. And actually, personally, I think it was less the cytometer's performance, more the fact that users were now trying to sort without understanding how to even gate strategically for cell sorting.
well, I told the manufacturers this when they came out with the instruments. I said this instrument won't need a core to do it. You can do it in your own lab. I said that's a mistake, because then if you make it, that's how you advertise it, then people will just generate garbage data and they'll complain about your instrument, and then you'll get a bad reputation. I said you don't do it that way. You got to put it in cores. But people had the money and they were willing to buy it for their own lab, and then they complained about why it didn't work.
And it really was the case, I think.
Yeah, I mean, I remember in the 2000s when we were doing 18 color experiments and so on. Postdocs would come to my lab because they wanted to do these experiments, and they said, I want to do an 18 color experiment, and this is the panel I want to use." And I just let them go, and they come back to me and say, "This doesn't work at all. This is complete crap." And I say, "No, the problem is that you have to build it up step by step." And then we go back and build it up step by step, and it would work. It would take 6 months, but it would work eventually. And the problem was that they simply, what I thought about was, this is what goes on in 80% of the labs worldwide, where people will try an 18 color experiment and it doesn't work, and they say, "This is crap, it'll never work."
I I'm going to I try not to get too technical, but I have to ask this question from this line of tools. Do you think spectral analysis made that easier or harder?
It makes it easier because the spectral is much more forgiving for the dye and reagent choice. And so, because it has higher resolution, so I think spectral in the end will be. I mean, that was always where the technology was going. And I mean, I remember when the first exposure I had was from Los Alamos, where they did a spectral machine back in the, I think, 80s. And I thought, this is very cool, but they didn't have the compute or chip power to do it in a reasonable way. So I had to wait until the late 2010s, I think, before they started becoming feasible. But yeah,
Right.
spectral will make it easier, but I worry then that there might be other things that fall by the wayside, because they won't qualify their panels quite as well as they used to, because they try a 12-color panel, it works, and that's enough for them. But you can get it so much better.
What do you think the maximum number of colors will be? Do you think there's a maximum number that we can ever use?
I think so. I mean, it depends on the dyes. I mean, given technology, it all depends on how wide the dye emission is, right?
Yeah.
And generally, the dye emissions right now are about 40, 50 nanometers wide. So it's a matter of divvying up the emission spectrum for each excitation laser. So right now we're at seven lasers by maybe 8 colors each. So 56 is probably a maximum there. But somebody someday may come up with a new technology where the emission spectrum is only 1 nanometer.
Yeah.
Right now, that's the entire future of more colors, is to narrow the emission spectrum, nothing else.
Lanthanides do that. So lanthanides have got really narrow emissions. Just need good lanthanide chemists.
And you don't have very many of them.
Don't need a lot.
Right?
A probe is tiny. Kaz, who's been your inspirations in your career?
Well, of course, initially it was my father, because he guided where I should go. But I would say then it was primarily Bob Murphy who introduced me to flow cytometry and the technology and so on, and then Len and Lee Herzenberg were really, they taught me how to run a lab and how to do science, really, and how to present it to the outside world. I mean, there's things that people forget about. You have to not only design experiments and implement them, but you have to be able to publish them and talk about them in ways that people will understand and appreciate. And that's something that Len Lee taught me very well. And I think I've been fortunate to be able to give seminars all over the world to many different people who are interested in the technology and hone that skill. But there's nothing like being able to present.
Of all the places you travel to, is there a favorite place?
No, I've been fortunate that I've been able to travel widely, and I can't say that there is a favorite place. No.
Kim? What about the best time in your career? When would you say was the golden era? If you could relive a period of your career, when would it be? What stage?
Well, that it's interesting because there's two different answers. In the flow world, it would probably be in the 2000s, early 2000s, because that's when we were doing development at a very high rate of the colors and the multicolor technology. In terms of my career, it's really been the last few years as I transition away from doing flow cytometry. And I've been tasked with doing a lot more medical countermeasures to different viruses. And I have groups that are doing uh, Nipah virus, norovirus, alpha virus, and SIV, HIV, and TB. I have people doing those in my lab. And we've been able to publish a lot of high impact papers on those topics in the last 2 or 3 years. So in the post-pandemic world, it's been less technology development, more biology development.
And so, best times you had two. What about the most challenging or difficult times?
I think that for me is pretty easy. That's when I was in early in graduate school and also in undergraduate. And that's primarily because no one ever told me what was expected of me. So, for example, in graduate school, when I went to defend my thesis proposal, the faculty actually came to that with the intent of kicking me out because I was viewed as somebody who was lackadaisical and not very hardworking and so on. But I did a very good job, obviously, and hit a home run on my proposal defense, so they let me stay, and I got my PhD, and then my career went on. But I would say that the last few years as an undergraduate and first year as a graduate student, I was not well prepared, and I didn't know exactly what I should be doing. And they were difficult years in the sense that I didn't know what I was going to do. I didn't know how I was going to get out of it.
So,
And that I have to give Bob Murphy a lot of credit for because he kind of pulled me along and taught me what work ethic was and how to get it done, and that helped a lot.
yeah, that's really, it's cool to hear that the support you had, so your inspirations and just how much support you had off your inspirations as well. During those difficult times, or even later in your career, there's always bad days at work.
Of
When you
course.
get home, what do you do to relax? What are your hobbies?
Um, my hobby was always science. I worked a lot as in my postdoc and as an early career. I worked at home. I would work a lot, and that was not so. I didn't have a whole lot of hobbies. I did do a lot of running. I developed into a runner when I was in as a postdoc at Stanford, and used to run quite a bit. And then when my son became was he was born in 26 years ago, and he's now an ultra distance runner, and he does a lot of marathons, and he's done some 100-mile races, and so it's kind of rubbed off on him.
I've got to ask, what was his 100? How fast can you do 100 miles?
He's done it a couple of times. He did it in 28 hours. He did Leadville, which is at 10,000. It starts at 10,000 feet altitude and goes up from there.
Oh,
Goes up to
okay.
12,000 and then goes down, and he has to turn around and go back up and down. So it's quite the 100-mile race.
Actually, sounds really cool. I've done 100 miler,
Yeah.
so and I would love to do it again, but my running partner got so injured, he refuses to do it. It's like, oh, come on, you can do it one, but no. And my family aren't that way geared to it, so.
It requires a whole lot of dedication. That's right.
Ah, but it's lovely. It's
Yeah.
lovely. So, what was your distance when you were running?
Primarily about 10K. I've done a marathon, and I was training to do another one, but my running career ended about 15 years ago. And but 10Ks were primarily my distance, and I would do that in about 40 minutes. So it was a pretty good pace, but
That's a good time.
not spectacular, but that's good.
I haven't done that for a long time.
Yeah.
40 minutes. I still struggle to get down below the 42 these days. Uh, do you miss it?
Yes, I do.
Hmm. And do you not find another hobby to replace it or displace some of the?
No, yeah, I do now. I do hiking and swimming. As the body gets older, you try to be a little bit less harsh on it.
No, because you keep yourself fit, so it's
Yeah,
good.
I try.
Swimming and hiking are clearly two things. What about cooking at home? Do you cook?
Not much. I'm fortunate to have a partner who's a very good cook, and so, there's no reason for me to do it, but I taste.
On that note, let's hit some quick fire questions. Are
Okay.
you an early bird or a night owl?
Early bird, absolutely.
PC or Mac?
Mac. I
Okay.
converted the entire VRC to Mac, which I'm very proud of, the Vaccine Research Center at NIH, because primarily because of FlowJo, but also because of other things, right?
I was
Absolutely Mac, completely.
about to say, because FlowJo used to be Mac only, didn't it? And then I
Yes,
remember getting the PC
exactly.
dongle. Okay. McDonald's or Burger King?
McDonald's, their
Ah,
fries are much better.
yeah, they really are, aren't they?
Yes, they are.
Yeah. Uh, tea or coffee?
Oh, tea. I
Oh,
can't stand coffee. I'm a bitter super taster, so I don't drink coffee and I don't drink beer, so I drink tea and wine. I feel like a left-hander in the beverage world.
I love that analogy. That's really cool. Chocolate or cheese?
Look, I'll come back to that in a sec, but I remember my first ISAC meeting was actually in Cambridge in 1986 or 7 or so. And I thought, finally, I'm going to go to Cambridge, the home of the tea drinkers, right? I'll be able to have tea easily enough. And so the very first breakfast, we sat down in the big hall there, and they were serving coffee. I said, "Can I get some tea?" And I had to go in the back room and get some tea for me. And it's just because the meeting was dominated by non-British people. It was primarily coffee. But I was so disappointed by the fact that I was being served coffee in my first trip to Great Britain as a scientist.
That's brilliant. Um, chocolate or cheese?
Oh,
Okay, I'll give you E. What's your
I mean,
favorite food?
cheese in general. I love cheese, so but I like chocolate too. But cheese, I think, is a little bit more interesting in the long run.
Okay. Uh, what's your favorite food? If you could be served any food, what would you like to eat?
Pizza.
Oh, okay. You can't just stop at pizza. What topping?
Oh, well, that would be my absolute favorite pizza is sausage and green pepper.
Okay. I'm definitely a pepperoni fan. Definitely
I
pepperoni.
find pepperoni a bit salty, so
Yeah, I like the smokiness. If you get a nice smoky pepperoni,
yeah, that's if you that's the standard pepperoni that all the American pizza chains use. But if you get good pepperoni, then absolutely.
that that's a good choice for a favorite food. And what about your least favorite food? What is your food nightmare?
I grew up my mother was German, and so I grew up not allowing to have unfavorite foods. But primarily the things I won't eat are the really bitter foods like Brussels sprouts. It's about the only food stuff that I will not eat.
Well, that there goes a classic Christmas British dinner that always has Brussels sprouts on the plate.
Well, I have to say I've had Brussels sprouts that were very good and tolerable, but they have to be very caramelized. They
Yeah,
have to be cooked and caramelized very heavily, and then they're tolerable for me, and I kind of like them.
yeah,
But
chopped up, nicely fried, caramelized. Yeah, okay,
yeah,
I can get it.
deeply fried.
Do you prefer to eat in or eat out?
I always prefer to eat in
Ooh,
if it's a good food.
that you're lucky you said that because you already said it's your wife that cooks, and if you'd have said eat out, she'd have
Uh,
gone mad at you for saying that.
no, but for example, when I invite myself over to my boss and his wife are very good friends of mine. I will always prefer to eat in because they're both very good cooks.
Being as you don't do much cooking, do you do the cleaning?
Of course,
Like,
that's only fair.
I I agree. That's why I prefer to cook because I can't stand cleaning.
Yeah.
Uh, TV or book?
Nowadays it's TV. I haven't read a book in years.
Okay. And do you watch any trashy TV?
You mean what's my? Uh,
Yeah, what's your TV sin?
Not really. The only thing I do, I tend to overwatch the reruns of old shows like Friends and How I Met Your Mother and so on.
Okay.
But I do like to stream the latest series on Apple TV or so on Netflix.
And what about your favorite film, favorite movie?
There's so many. It depends on what choice. But being there with Peter, what's his name? It's based on a novel by Jerzy Kosinski. It's one of my favorite movies. It's called Being There.
Okay.
Came out in the mid-80s. It's a fabulous movie. It's about basically, I thought it used to predict the rise of George Bush Jr., but in fact now I think it's the rise of Trump that was predicted by that.
That
But
that could be worth a watch, actually. And I think anyone who's watching or listening to this may now be scrambling to watch it because it sounds fascinating. Are you a Star Wars or Star Trek fan?
oh,
Both. If you had to choose one?
Star Wars.
Oh, yeah, I think
Sorry.
I'm in the majority. And what about favorite Christmas movie?
I'm not a fan of the holiday movies, but probably Elf.
Okay, that's quite popular too. Spectral or compensation?
Same thing.
Ah, come on, one's additive, one's subtractive.
No, it's exactly the same math.
We'll argue that one at a different time. But how can I argue it with you? Okay, so you just
Spectral is the way of the future and how you have to do it. And the data is you get much better resolution with spectral, but there's really no difference between spectral and compensation.
okay.
Mathematically, they're equivalent.
Fluorochromes or metal tags?
Oh, very definitely fluorochromes. You can't sort with metal tags.
And no,
That was Led's complaint. He said you'll never get any cells. We can't do anything with them if you tag them with metals and blend them up in a 4,000-degree oven.
what's your favorite music?
80s,
80s, okay. And what's your favorite color?
purple.
Oh, of all the people, I thought you might say PE or Fitzy or Rhodamine. No, purple.
I can give you the wavelength if you want.
Sorry?
I can give you the wavelength.
Oh, go on. What's your favorite wavelength?
Maybe about 470.
Mm. That's a really good quote. I really like that. You got to get a T-shirt made with 470 on it. Why 470?
I don't know why anything. Yeah,
Okay.
I sous vide a lot for cooking meat. And so I know the temperatures that I want different meats that I want with my sous vide. And I went to a restaurant that very proudly said, we sous vide all our meats. And they said, well, what temperature do you want? I gave them a set. I said 131. He said, I don't know what that is. He said, do you want medium rare or rare? I said, you advertise that you can do it to whatever temperature I want. And so, this was kind of disappointing to me that they advertised it as you could name the temperature, but didn't expect people to actually name the temperature.
Yeah, and I guess I did. Well, you said what wavelength, so I guess I did walk you into that. Uh, do you have any pet hates? Things you really dislike, people's habits that you dislike, or what do you find? Where's your tolerance quite low on?
Too many to list.
Sorry,
Too many to list. I
too
think
many to list.
my primary pet peeve is people who don't try. It's not making a mistake or it's not, doing something wrong. It's when you don't even try.
So,
Lack of effort.
so for all your lab that are listening to this back, there you are. Make sure you're putting in an effort because otherwise you're not going to be happy with them. Uh, Over all your career, do you have any regrets?
No,
No.
no, I can't imagine doing. I've been very, very fortunate throughout my career in the choices I ended up with,
Hmm.
and I can't say that I would could have chosen any better or differently.
And if you could do any job for a day or a week, not science, what job would you choose to do?
That's a great question. Uh, I imagine being president of the United States would be fun if you only got to do it for one day.
Mhm. That's what I say. You kind of need it for a week, don't you, to get a proper flavour, and then cut and run.
Yeah, exactly.
That's cool. Ah, so if you were president for a day or a week, what would you do?
Oh, that's easy. I'd cut the defense spending in half and I'd apply it to NIH budget and to science.
I like the dedication to science itself.
Yeah.
What is what do you think has given you most reward at work? Has it been the founding of FlowJo and just how many people have used it? Is it the all the different multicolor panels that people have picked up and run with and be pushing the limits of multicolor flow cytometry? Or has it been your latest development in looking at the disease and going
Well, the way
overseas?
I think of it is I enable science, and that's been my greatest pleasure and honor is to be able to enable science at many different levels, at the level of technology, at the level of biology, at training people. And really, there are a couple of small things that give me great joy. It's like when somebody asks a question on the Purdue list about compensation, and somebody else answers it absolutely correctly, and that gives me great joy now that it's I've taught people about compensation or spillover correction, whatever you want to call it, and there's enough people out there that know how to teach it to other people now.
Hmm. Now, I
That's,
think
in fact, that's why I rarely respond on the Purdue list. I used to respond all the time, but now I let other people respond, and I think that's really my joy is that the I think the next generation has taken up the harness and taken up the efforts, and they're doing a great job of it.
I, I do see you reply sometimes still. So what triggers it?
We're mostly pithy, and I try to inject a little humor, which some people don't find very humorous, but my sense of humor can be very biting.
That's I think a wise head as well, and being knowing how to use it, and actually by not commenting, you're letting other people build up their reputations.
Exactly.
So
And seeing my trainees, become successful on their own right has been a great joy too. It's like raising a child that goes and does something great.
any thoughts on social media?
Yeah, I mean, it's been coming and it's absolutely necessary. The problem is identifying what is the truthiness of the social media is what's at stake here, right? And that's a real problem. But nobody knows. There's so much social media that a lot of it is just not correct. That you're saturated. I hope people will finally get to the point where they stop relying on social media for their input. But I suspect that there'll always be too many people that get their information from Twitter or whatever.
And there's a lot of good science on social media, whichever platform that you're looking at, whether it be LinkedIn or Twitter or Blue Sky or whichever one. I think there's some good scientific communities out there. And I noticed, I looked at you on social media and I found two Marios on Twitter. One which I think is genuinely you, and another one that is at Facts God.
That's probably me too.
I thought that was brilliant. I saw that. I thought so wanted it to have loads of activity because it said at Facts God. And then I saw the other one that has more activity, which is at Mario Roederer. But that that was a brilliant name, and I thought that was beautiful as one of the
I thought of it and registered it for myself so somebody else wouldn't get it.
and I think as one of the gods of flow cytometry, it's a really good name. But then you might have to share it with God 1, God 2, God 3.
Exactly.
A few of you that's out there. Before I finish, you ever got any words of wisdom for any young scientists out there, or even any older scientists out there?
Yeah, share what you're doing. One of the things that Len taught me was to be very collaborative and to always talk about what you're doing. Don't withhold information or data, because science will proceed much more rapidly. Everyone is so intent on taking uh, ownership of something so that everyone knows that they did it. And that's not really what science is about. Science is about sharing and doing it collaboratively, and you'll get recognized anyway. But I remember being absolutely horrified because Len would give a talk sometimes, and he'd tell everyone about the data I'd collected a week or two before, which I thought was pretty hot data, and now he's spilled it out to the entire world, and I thought, oh, they're going to run with it and take it away, and that never happened. But what did happen was that people wanted to start collaborating with Len or then with me, and wanted to work with me, and I've been extremely fortunate to have had a whole slew of very, very productive collaborations in my life. And if you look at my publication history, I have like 400 papers or so, and I would say a vast majority, probably 80%, were collaborations that came about. Only about 20% are from my own lab, or only from my lab.
Well, of those 400 publications, I think it's got a H index of over 100, I think. And for
Yeah,
those who don't know what that means it is phenomenally high compared to almost all academics. To be over 100 is a stellar performance. And I also noticed you in the Stanford University Invention Hall of Fame.
yeah.
That's pretty
That was
impressive.
for Science 7 PE or Science 7 ABC, which netted Stanford about 10 million in royalties.
Do you get some of those royalties yourself?
I did for a while.
That's nice, isn't it? That,
Yeah.
that's that's super cool. And I have to ask one more question, which I nearly forgot. Your dad was a physicist. Your brother was a neurobiologist. You've gone into from biophysics into biology as well. What about your son?
About what? My son?
Yeah.
He's defending his PhD in virology at Harvard in 2 weeks.
Oh wow! So he's also followed the same footsteps.
Yeah. But he doesn't want to do bench science. He wants to go to a startup company or do business development.
Okay, yeah, but you had the company, so that's not so dissimilar. He's just
No, he just wants to start there. I did not start there.
yeah, okay. But I guess he's seeing what you can do with a company as well through that, and
Exactly.
I hope his defense goes well into a
I hope
couple.
so too.
And Mario, thank you so much for joining me today. Thank you everyone who's listened or watched. And please, you can see Paul Robinson and some of the other people we've talked about, and you'll see Dave Novo up and coming if you're watching this as it's just released. But Mario, on behalf of the community, thank you so much for being an inspiration to us. Thank you for helping lead and develop and giving us the tools that we are also dependent on and just take for granted in many cases. And I hope you realize just how big an impact you've had on the cytometry market. And thank you for taking your time to join me today.
It's been a great pleasure, and thank you for saying that. Those are very nice things.
Thank you.